Hello. So it's a little bit late in the afternoon. I guess you're a little bit sleepy. So how many of you are writing code right now? Raise your hands on your laptops. Come on, don't be shy. Good for you. Okay. So I came here trying to improvise. I have not prepared the speech. So let's try to make it a little bit interactive. I'll tell you what we are doing. I will not dive into the smallest details of how we do the things we do. I'm most interested in why we're doing it and what are the benefits. So let me see. I don't even know the slides. Okay, so this is Beyond Bots, Agentic AI. This is what we are doing over in Intracom Telekom. So we've been trying our hands on AI since 2015, I think. We started with big data in 2011, and so we failed miserably many times, trying various techniques, various organizations, various teams, various things. At some point, I think we found how to do it, and so we started with what can be called classic AI or quantitative AI. So who can propose a term for AI that is not agentic, is not generative? Agentic is after that. Is there a single term? Do you know about that? I don't think there is. So there is a big confusion, I think. So I'll tell you, I will start with the biggest problem that we have when we're trying to implement such systems and solutions, and nobody understands what we are saying. That's the biggest problem. Okay, we go there trying to explain how perfect our performance, accuracy, and stuff like that is. Nobody cares. So that's the first problem. I go there, enthusiastic to explain what type of model we used and what guardrails we put or whatever. Nobody cares. So what everybody cares is only the end result, and this is, I think, the biggest lesson that we've learned so far. So let me make another question. How many of you have managed to place an AI system in production? Raise your hands. Let's see. 2. Not much. Okay. Machine learning systems. Okay. How many of you have tried into putting production bots, chatbots, voice bots, whatever? You're the συνήθις ύποπτος. Okay. Great. Okay, let's go to the next slide. I have some questions about you. So this is a system that we're trying to do. Okay, so what we're trying to do is make RAG work. How many of you have tried to make RAG really work? Okay, do you know what RAG is? Hands? All of you? Not really. Okay, RAG is trying to use your own knowledge to make the bot answer on your own knowledge. Okay, it's much more complex. It's supposed to be very easy, very simple. It was the first use case. It's one of the most difficult to make it work in a good way. So this is the end result of our tries. I'm not getting into detail about the whole structure, but what we are doing is the first lesson. We are trying to give a complete solution. Okay, so the solution starts from the interface, which we see bots as interfaces, and then we provide a solution that includes the whole management of data for big organizations, and then also analytics, how it works and why it works and why it doesn't work, and so on and so forth. On-prem infrastructure, how many of you have tried local models, tried, Llama and things like that? How many of you are using it with API? Okay. So I don't know what you believe, but I believe that the future is the local models, of course. Okay, we cannot rely on APIs. So the second lesson is to make your system be independent. how you make it independent is not to rely on a single model. So you have to make it able to connect either through an API to a model or to OpenAI, Anthropic, or whatever, and locally. So that's on-prem. And how about that, multi-agent? How many of you have tried a multi-agent system, not agentic, a multi-agent agentic system, with an orchestrator and stuff? Nice. What's the problem that you see? Did you face any specific problem? Feel free. If not, no. Right. So did you do it with a no-code system, or did you go put your hands on and build everything? A hackathon, nice. Okay, so I'll tell you what the problem is with multi-agent and agentic systems in general. The performance is the problem. Okay, every agent supposedly is trying to talk to an LLM. And if you try to do this thing on a real system, it's a complete failure. So what we see is that you start, enthusiastically, great, I'm building a multi-agent system, and then you try to make it work with 3 users at the same time, and you need 10 GPUs. And then you start the other way around. Maybe this, make it like hit a database, okay. Maybe this, make it to hit an XLS file, and then you try to minimize hitting the LLMs only once, and only when it is necessary. So this is the other problem. Everybody's excited about this technology, but really making it work is really, really hard. And although I cannot say who is the customer, we have a request about handling 100,000 users talking concurrently on the bots, and we said, that's lovely. Maybe we should only sell you the hardware, not the software, because he wanted to do it on-prem. And you said, beautiful business, please. And he said, no, give me the specs. I said, no, it would be nice. So performance is a great problem, okay? Of course, the other problem is the price that they see at the end. They believe that they should do that, with like using a standard NLU, an old-fashioned system. It's not the case. So agentic systems and performance. And how many of you have tried your hands on guardrails? Really, I mean, trying to guardrail an on-prem LLM. Have you tried it ever? Yeah, I'll tell you, it's a big pain. I was in a business trip talking with a great guy that is putting agentic systems in production in a major bank in Switzerland. So he told me that in order to do that, he has like 5 layers of defense. So the first layer is the data scientists that their only job is to break it. Okay, and then they try adversarial prompting to break it. Then they try to have something else. Then they give it to all the employees to break it. And after 1 month and something of really hard testing, they try to put it into production slowly. Because this is a bank, of course. Okay. So that's the other problem. Guardrailing is really hard. So if you try your hands on with APIs, it becomes simpler because you rely on the provider of the model. If you try it yourself, it's hard. Okay. What else? Dashboards and stuff, easy. Finally, another question. Have you ever tried, those of you who have tried, to make an agentic system to run on the back end, not to have an interface? This is something that we are doing, and it's really nice. So that's the title of my speech, going beyond bots. So instead of using the LLMs and the agentic system as an interface or as a knowledge base, to have it as a back-end system that does the job, and having a normal application, a normal user interface working, but instead of using a normal code, using internally an agentic system to do stuff. There are amazing things to be done, And this is what we will start seeing, I think, in the future, slowly. So this is one slide. Any question? Any comment? Please.
Can you explain further what do you mean, like putting GPU in the backend, like doing some offline work and harvesting the results, or something else?
Yeah, I can give you an example. There are some banks that are doing demand reloading. This is a classical, very expensive software that uses classical methods statistical methods mainly. So it doesn't have a real user interface. I mean, it's a backend system that controls, audits all the transactions that pass by. So you can try to make this with an LLM. So no bot, no interface, no prompting, nothing. It's a backend system that is used to check transactions, if they're fraudulent or not, using LLMs. So this is an agentic system can be, or maybe not because you need it to be very fast, that uses generative AI for something that is beyond bots. Okay. So bots are nice. It's going to be the first things that we're going to be seeing, but the real job is to use it underneath the hood, as they say, to do the job faster. Oh, next slide. Okay. So this is the other area that we are busy with. It's, Intracom Telekom is a telco company, so we're doing a lot of difficult stuff with big data on the network level. A network creates lots of data, you can imagine. So a telco operator like OTE, that is hosting us, you see us, hello, is keeping all the data of everything we are doing. So there are fantastic use cases to do here in many areas. And this is the second part of my speech. So what we are trying to do, and all the community of the telco companies are trying to do, is to use these new techniques to create what we call hyper-autonomous networks. So up to now, these networks used to be, you used to have a lot of people trying to put their hands on and solve problems, look at the performance. And now, what the community is trying to do, and we are involved in such a, for the time being, research program, we're trying to have the operators using prompts to do whatever they're doing. So we hide the whole complexity beneath using an LLM system. So I can give you an example, because probably you're not aware of what the networks are doing. So one of the biggest pain is to optimize the network, to make it use less resources or less energy, which is a great thing. In order to achieve that in a network like OTE's network, which consists of maybe, I don't know, the latest numbers, maybe close to 5,000 base stations all over, Greece, that's a big issue. So what now the community in the telco world is trying to do is using prompts as intents. That's the buzzword in the telco world. So it's intent-based. What is my intent? Is my prompt, actually. I want to minimize energy consumption by 2%. So you just give that to a system, and then underneath, it tries to run simulations. It uses digital twins to try to, switch down a little bit the transmission power in some base stations and do other stuff with configurations, and to do all that automatically. So you may have a digital twin used to do the tests, and you may have like two LLMs, one trying different configurations and the other one testing it if it is working and giving back the results. So this is really exciting for me. It's a great use case for generative AI, and this is completely beyond bots and beyond what we normally see. We do a lot of other stuff. So from this slide, what you see, only maybe one or two are based on generative AI. All the other ones are machine learning stuff, which are usually much easier to do. Okay, we really like them now. We consider them very nice to deploy compared to generative AI. Yeah, maybe this is a video. It is, isn't it? Looks like a video. Okay, this is one system that we have created This is a typical, not typical, this is machine learning. This is not generative AI as an example. Here the use case and how we promote that is we don't go around saying we have a neural net that does amazing stuff, and we only say that we minimize your energy consumption by 30%. That's the only tagline that we need to use. Underneath, this is very interesting technical-wise because this is a real-time system. So we do prediction of the traffic of a network in real time for the next very small time window of 2 seconds. So the challenge here, the engineering challenge, was to make it run that fast and to have all these predictions running. And then we do a lot of stuff with trying to minimize the energy consumption. This specific example is an example on a data center. Well, in a data center, and now with AI or a classical data center, what you have multiple servers running, but usually you have an elastic software or an elastic software layer. So that means that if you have a need for a lot of resources, this is elastic. The system, cloud, Amazon, Google, or whatever you have, it gives you more resources, right? Or if you have your own on-prem data center running Kubernetes or an orchestrator, this is automatic, elastic, up and down. But the whole problem is that the hardware underneath is not elastic. Okay, so when you're not using a lot of resources, if you have your own data center, which is on-premise, the hardware still draws a lot of power, and this is a big problem. And now that, in Greece what happens, everybody's trying to build new data centers, all the companies in Greece. We will not know what to do them, I'm sure. There are going to be so many. And nobody's, that's a small parenthesis, nobody's taking care of what type of software it will run. Okay, all these are going to be AI factories, but with no software stack. So nobody cares about that. Just build them, like Greece. Let's build an auto-way. But nobody is doing the other job. But anyway, going back, so you have your data center doing all that. You need to switch it off. And this is what we do, actually. We monitor all the workloads. And when we see that the workload is falling, I guess, this is the next one. The workload is falling. We empty servers, so we move the containers around, and then we switch them off. And when we see that the workload is increasing, we take them back, we switch on the servers first, and then we distribute the workloads. So again, this is beyond a bot. Okay, this is something really exciting for me. This is another use case where we managed to minimize the energy consumption of a server by 45%. And this is an example that you need good engineering skills to do something really useful. So in this case, what we're trying to do, we predict the traffic, and then we tamper with the clocking frequency of the processor in the server using very low-level libraries. By doing that, when we see the traffic falling, we clock down the processors and then up. So this is an automatic system that produces these amazing results, because in these coming years, this year, next year, we see the 5G networks getting into implementation. And this brings, they are going to use a lot of servers. So having these capabilities is really very exciting. So how many of you do know what slicing is in a core network? I hope nobody. Huh? Oh, great. Yeah, you should know, of course. Okay. This was put here just to show you an example that it's very nice to put an AI into production, but you need to know what you're doing. So if, for example, you're building a bot for a call center, you really need to understand how a call center works. Otherwise, you're just playing around. If you need to do something in a network, you really need to understand telco and what's the issues, what's the pain. Here, this is a very advanced, let's say, feature for non-telco people, is how you slice your network into virtual slices and give them to specific use cases to have specific capabilities. So if you are on gaming, and how many of you are on gaming? I'm here. Very few. Guys, you are too serious. So if you're on gaming and you're doing online gaming, you need the least latency, right? So if you're using a mobile network to do that, if you're in a high traffic area, latency goes up, and this is a disaster for gamers like me. So what you need a specific slice of the network that has a specific characteristic to be very, very fast. You actually don't go around with a chainsaw like Musk, to slice it. It's virtual, it's only software. So again, going back, the example here is that in order to build something like that and not to optimize it, and we have a software like that, you need your experts. You need what we call the subject matter experts, okay? So whatever you're trying to build, you need to be around one, or find one, or pay one. Another example, and time for questions. I thought there was another one. Okay, I think we are almost done, and this is the final use case that we placed in this presentation. This is how to, again, solve a problem like finding the best placement of things. Okay, it's a classic problem for AI. It's like similar finding the best route, like what Google is doing and what it did today. It failed miserably while I was coming here. While I was coming here, I was using Google Maps, and there was a traffic jam. So what the system decided to do, I was on Attikiodos, so decided that the best route was to come out on Lephora Pedelis. So I came out, and I had to go back in because there was a small congestion for 100 meters. So I was very relaxed because I'm so confident with Google Maps, the best software in the world, right? So I got out of the Attikiodos. I said, how am I going to go to OTE Academy? And then said, now you can go in. Thank you very much. Who's going to pay the bill? Okay, right. So guardrails. That's it. Questions?
You mentioned that you're using GPUs in the backend and LLMs. However, the problems you presented do not need LLMs. They need classical...
These are classical, you're right.
All right, okay, thank you.
So only the LLM-related ones are the call center, like bots and stuff like that. Use cases like anti-money laundering, which use LLMs without you seeing them. And these very advanced things that we're doing on the network, trying to give intents. Please do this for me. I'm a complete ignorant. I need to minimize the energy consumption, and underneath it goes like crazy and doing a lot of stuff. And you're watching the logs and going back and forth. Well, that's the whole idea. So I'm not a believer that everything should be, LLM-based. I mean, I'm very much supporter of rule-based systems if they are faster and they do the job. Yeah.
Thank you.
Thank you. Thank you very much.